Welcome to my first tutorials in Java programming. My name is Dr. Thomas Yeboah from Christian Service University College, the Department of Computer Science. My first lecture, I want us to look at variables and constants. Variables and constants. Now, before you proceed to the details of the topic, I want us to look at the learning objectives of the topic, variables and constants. So, learning objectives. At the end of the period, I'm expecting candidate 1 to define variables and constants. 2. Declare variables and constants in Java. 3. Explain why variables and constants are declared. 4. Understands naming rules in Java. And 5. Differentiate between symbolic and literal constants. So these are the learning objectives I want candidates or students to achieve. First, you define variables and constants. 2. Declare variables and constants in Java. 3. Explain why variables and constants are declared. 4. Understands naming rules in Java. And 5. Differentiate between symbolic and literal constants. Now, let us look at the definition for variable. How do you define a variable? Now, to define a variable, I want us to look at the following. An elementary maths teacher asks students to memorize two numbers. So, for example, the numbers can be 5 or 2. Now, after memorizing the two numbers, the teacher asks the student to add 1 to the first number and multiply the results by the second number. So, when you look at it, the first number is 5. So, we are going to add 1 to the 5 and multiply the results by 2. So at the end of the day, you should be getting the results as 12. So the result should be 12. Now, why are you doing this? We are doing this because we want you to understand that even before human being can process any data or perform any action in any data, the human being is supposed to store the variables or the data items before any calculation or any operation can be performed on it. For example, you need a place to store the 5, you need a place to store the number 2, and even the place to store the results 12. So the same thing applies to computer system. Anytime computer want to perform any calculation or any operation, we need a memory location to store the various variables, because you cannot do it without instructing the computer to reserve a memory location for you. And to do that in programming, we need to declare a variable. Now, let us look at the actual definition for a variable. A variable can therefore be defined as any named memory location in which data is stored and can be retrieved. So when you look at the definition, a variable, there are some keywords. A variable is supposed to have a name. Variable is supposed to have a name, and there should be able to store the data, and at the same time, if you want to retrieve the data, you should be able to retrieve it. So these are the key components in the definition: a name memory location, able to store data, and it can also retrieve the data. Now let us to look to the naming rules in Java. You see, a variable is supposed to have a name, as you saw from the previous slides. But the name that we are going to give to the variable is supposed to be a standard one, or supposed to follow a certain rules. So the following session or slide is going to give us the naming rules in Java. So number 1, the name should not be a reserved word or Java keyword. For example, when you take Java programming, there's a scanner. So if you want to input something into the computer system, you need a scanner class. You need to call the scanner class. So the scanner is a reserved word in Java, or is a keyword in Java, and therefore you cannot use that one as your variable name. So number 2, the name must start with a letter. All the names that we are going to give to a variable should begin with what? A letter. So for example, when you take something like forerunner. Forerunner is a name. It sounds very clear in your your mind, but in programming, if you name your variable as a forerunner, it's wrong because from section 2 or point 2, you have seen that the name must start with a letter. So forerunner is beginning with number 4, and therefore you cannot use that one as a variable name. Now, number 3, compound names should be separated by underscore or be joined together. Compound names should be separated by underscore or be joined together. So these are some of the naming rules in Java. Now, variable declaration. How do you declare variable in Java? You see, before you proceed to the variable declaration, I want us to, or let us consider the following statement. A teacher said to a class, yesterday I gave some people work to do. Some did it, some didn't did. If you know you did it before I go out. Now, pause here. I can see you are laughing. Why? Because the statement here does not conform to the syntax of English language. So the same thing applies to Java programming. Because Java programming is also a language, then in order to speak it or in order to write it, you need to conform to the syntax of uh, the Java programming. So let's look at the syntax for variable declaration. Syntax. Now, in order to declare a variable in Java, what we have to do is we need to go according to the syntax. First of all, we need to specify the data type. The data type can be either string, it can be float, it can be double, it can be char, it can be string. So we need to specify the data type because the data type will instruct the computer the amount of memory that's supposed to be reserved for that particular data. And after indicating the data type, then the next component is the variable name. And as you know, the name should be here. So the name is supposed to conform to the rules that you have already discussed. And the last component is the end delimiter, which is semicolon. So these are the three components you can identify in variable declaration. First of all, we need the data type, for example, int, and the variable name, let's say my age, and lastly, the end delimiter. So in programming, without this end delimiter, the syntax is wrong. So let us look at example here. Example, have int my age. So when you look at int my age here, we can say that this int here is the data type and my age is the variable name and the almighty end delimiter, which is the semicolon. So these are the syntax for variable declaration. First int my age and the end delimiter. We are still on the variable declaration. So to summarize it all, first we need a data type to identify the type of data that you want to store. 2, an identifier, that is the variable name or the variable name. Then 3, an ending semicolon. And there's also fourth point, which is optional. It depends on the way you are going to do it. If you want a variable to contain an initial value, then you can assign initial value to it. So that is why we are saying this one is optional. If you are not doing initialization, then you don't need anything of that sort. So for example here, I have my int, which will be my my data type. I have my age, which is the variable name, and is equal to 5. And the 5 here is indicating that we have assigned the 5 to, or you have assigned initial value as 5 to the variable name my age. Now let us look at the reasons why variables are declared. Reasons why variables are declared. So the following are some reasons why variables are declared. 1. It indicates the variable name. 2. It also informs the compiler the data type to be used in the program. So when you declare your variable, it gives the opportunity to inform the compiler the type of data that you are going to use in the program. So without the variable declaration, the compiler cannot identify whether you are going to use this data type, whether int or double or float or string. So when you do that, it will inform the compiler the data type that you are going to use in the program. Now, number 3, it tells the compiler the amount of memory to be reserved. So once you know the data type, the compiler knows the data type, then it should also be able to identify the amount of memory that you need for that particular um, variable. Now, I want us to pause here because we have reached another section, which is constant declaration. Constant declaration. So constant is similar to variable declaration. The only difference is that constant does not change, but a variable change in a program. Now let us look at it. While a program is running, different values may be assigned to a variable at different times. But in some cases, we do not want this to happen. So in a situation whereby you don't want the item to change or the data item to change, then you might declare it as a constant. For example, if we are working for, let's say, Ghana Revenue Authority or Internal Revenue Service, we all know that the tax paid by individual is fixed. You can say Kofi Man will pay a tax rate of 25% and Yamansan will pay a tax rate of, let's say, 40%. It's fixed. So if you are writing, or if you are writing a program for Internal Revenue Service, so when you reach a section whereby we need to use declare a variable for the tax rate, then it means you have to declare that one as constant, not a variable declaration. So in other words, we want to log the assigned value so that no changes can take place. If you want the value to remain fixed, then you use a constant. A constant is declared in a manner similar to a variable, but with the additional reserve word final. So what we are trying to say here is that the the only difference between a variable declaration and, let's say, a constant declaration is that you must precede the concept by the keyword final. So for example, if you go back to the variable declaration int my age. So int my age, if you want to make int my age as a constant, then you need to write final before the int my age. So for example, uh, final int my age is equals to 5. Then it means the 5 is going to assign to my age, but that one is an integer value and we have declared that one as a constant. So the moment you remove, let's say you remove the final from the component, then it becomes a variable. So the only difference between the constant and the variable declaration is that is the keyword final. Now let us look at types of constant. Basically, there are two types of constants. We have symbolic constant and we also have literal constant. So to understand the two, symbolic constant and literal constant, let us consider the following two examples. So we have case 1. So case 1 is here. This is case 1 and this is case B. This one, you want to calculate the area of a circle. You all know from elementary mathematics that area of a circle is pi r squared. So in programming, you can declare the pi as a constant, but you can declare it either symbolic constant or literal constant. So for example, in case 1, you say final fruit pi is equal to 3.142 and double area. So you see, we have declared pi here, pi here as a constant, and we have assigned 3.142 to it. So when you go into the memory location pi, it is going to contain 3.142. So in the formula, area is equal to pi. So wherever you see pi, it will assume the value 3.142. Now when we come here to case B, we have declared area as double, right? But here we didn't assign the 3.142 to the any variable. We just type the 3.142 into the formula. So this one here, this one is a typical example of a literal constant, and this one is a symbolic constant. That is where you assign the constant value to a variable, then you pass the variable into the formula. But in a situation whereby you assign or you write the value into a formula, then it becomes a literal constant. Now I want to ask you a simple question. Looking at the two types of constant, which one do you think will be the most appropriate or the best one? So now having seen the two constants, guess the one you think is the best practice. So I want you to guess the one which is either symbolic constant or literal constant. Anyway, I hope you have guessed right. If not, the best one is the symbolic type due to the following reasons. It makes debugging of the code very simple, especially when the constants have been used at different instances in a program. For example, when we take the tax paid, if the tax paid is being used in several instances in the program, and something happens to the program, maybe the tax rate supposed to change, or the tax rate supposed to increase or reduce. So in this case, we need to go to all the instances and make changes to the value. But when in the case of let's say symbolic constant, it is only going to be affected by the variable, the value. You just change from the top, and it will take effect from all the instances that we have used the the value. So you see, in debug meaning checking corrections in a program, it makes it more easier when you use symbolic constants. Number 2, it also gives you the opportunity to specify the data type you want. For example, in case A, we specify float, but in case B, we did not specify the type it has to take. We did not specify the type. Therefore, it's supposed to take a double as a default. So what we are trying to say here is that if you don't specify the data type by default, it will take, let's say, a double. But in our example, if you use float, it can do it, and if you use double two, you can do it. But we are just wasting memory. So now let's proceed. Let's look at this, the Baba, because I can see you are tired. So let us look at this story, the Baba. A man went to a barber shop to have his hair cut and his beard trimmed. As the barber began to work, they began to have a good conversation. They talked about so many things and various subjects. When they eventually touched on the subject of God, the barber said, I don't believe that God exists. Why do you say that? Asked the customer. Well, you just have to go out in the street to realize that God does not exist. Tell me, if God exists, would there be so many sick people? Would there be abandoned children? If God existed, there would be neither suffering nor pain. I can't imagine a loving God who would allow all of these things. The customer thought for a moment but didn't respond because he didn't want to start an argument. The barber finished his job and the customer left the shop. Just after she left the barber shop, he saw a man in the street with a long, stringy, dirty hair and untrimmed beard. He looked dirty and unkempt. The customer turned back and entered the barber shop again. And he said to the barber, "You know what? Barbers do not exist." "How can you say that?" asked the surprised barber. "I am here and I'm a barber and I just worked on you." "No," the customer exclaimed. "Barbers don't exist because if they did, there would be no people with dirty long hair and untrimmed beards like that man outside." "Ah, but barbers do exist. That is what happens when people do not come to me." "Exactly," affirmed the customer. "That is the point. God too does exist. That is what happens when people do not go to Him and don't look to Him for help. That is why there's so much pain and suffering in the world. So be close to God so that um, you don't suffer from this problem." Thank you very much. I think we have to end here, and I believe next week we are going to have our lecture 2. Thank you, and have a nice day.